Now, when it comes to trigonometry, there are certain identities that one has to remember every other time and have in mind because they are useful in trying to navigate the kind of problems that appear in your examinations. So I want to consider some proofs of trigonometric identities, and so one should be show that, let me say, of course, so we have this 14th of this 2024, it's the day today, okay. So show that, show that, show that, show that. 1 tan of theta plus cot of theta is equivalent to sec theta plus, no, sec theta cosec theta, sec theta cosec theta. Show that tan theta plus cot theta is equal to sec theta cosec theta. Actually, sec theta times cosec theta. That's Roman 1. Then Roman 2, show that tan squared theta minus sine squared theta is equivalent to sine raised to power 4 theta sec squared theta, sec squared theta. So that's what we have, and those are the two kind of questions that we want to look at, and it will be a lot as we solve. It will be reminding us of some of the useful identities that we'll be applying as we seek the answer. So solution 1, that is Roman 1. Now, to show that tan theta plus cot theta is this, that is to say, let's remember that tan theta, okay, we just write it as it is. Okay, tan theta plus cot theta is equivalent to sec theta cosec theta. Now, this is what we need to prove or show. So we start by saying tan theta is supposed to be sin of theta over cos of theta. That's what we have. And cot theta is actually the reciprocal of this, which will now be cos of theta divided by sin of theta. That's what we have. Cot of theta is actually the reciprocal. Is the reciprocal of tan theta, not the inverse of tan theta, the reciprocal of tan theta. So I'll be substituting where there is tan theta, I'll be writing this here, and where there is cot theta, I'll be writing this. So effectively, what I have then is sin theta over cos of theta plus cos of theta over sin of theta. That's what I have. And I should then see what my LCM is, because for me to bring them together, I need to consider the LCM. And my LCM is basically cos theta, sin theta. So I'll write here sin theta, cos theta as the LCM. And then that simply means that I'll be having sin squared theta here plus cos squared plus cos squared plus cos squared theta as such. So I have, that leaves me sin squared theta plus cos squared theta over cos theta sin theta. And we should remember, so we say, remember, sin squared theta plus cos squared theta is equal to 1. So it means the whole of this I can substitute with 1. So I say that implies that I have 1 over sin theta cos theta. 1 over sin theta cos theta. And 1 over sin theta cos theta is what we refer to as sec theta cos theta. So this is sec theta cos sec theta cos theta is given by this. It simply means we are now having here sec of theta times cos of theta is equivalent to having this. So in other words, again, sec theta cos theta again is also the reciprocal of the whole of this. So, and that now, that's the proof, because we have shown that we can start. Now, when you're asked to show, it simply means start from this end until you get here. So we began with this and we are here. And so that is how we should show for part 1. Now part 2, just rub this. Part 2 will then be part 2 will be this. So we set out from this end. So we'll be having tan squared theta minus sin squared theta. So Roman 2, as we see, we are supposed to show that tan squared theta minus sin squared theta is equivalent to sin raised to power 4 of theta sec squared of theta, sec squared of theta. So tan squared of theta is sine squared of theta over cos squared of theta. So I can say that, can start by saying sine squared theta over cos squared theta, that is this part, minus sine squared theta as such, but now I say over 1. I say over 1. And so I need to simplify that. And to simplify this, I see that so what I'll do is that, being that I have sine squared theta over cos squared theta minus sine squared theta over 1, it means already that from here, it's possible to it's possible first to factorize sine squared theta. So I'll be having sine squared theta in bracket 1 over cos squared theta minus 1. Minus 1, like that. That's what I have. And from there, I can comfortably say that sin squared theta, what is this particular part here? This particular 1 over cos squared theta. So that allows us to write sin squared theta sec squared theta, sin squared theta, sec squared theta, sec squared theta, in bracket, not necessarily because we have already done away with that, so we have removed the bracket. So we say minus this times that, which is just minus sin squared minus sin squared minus sin squared theta. So again here, if I factorize sin squared theta, if I factorize sin squared theta, then I'll be having sin squared theta in bracket sec squared theta minus 1. That's what I have. Sin squared theta in bracket sec squared theta minus 1. But what is sec squared theta minus 1? Sec squared theta minus 1 is equivalent to tan squared theta. So that you need to find out. So basically what we say, but tan squared theta should be sec squared theta minus 1. Therefore, where there is sec squared theta minus 1, we can substitute this. And so that leaves us with sin squared theta, sin squared theta, tan squared theta as required. Just a moment. No, it's not that. Tan squared theta. And okay, so once we have that, we already have sin squared theta over tan squared theta. So this part here, tan squared theta is equal to sin squared theta is equal to tan squared theta. But you see, our answer does not require us to show that sin squared theta, tan squared theta. Our answer requires us to get some sec here. So we'll need to represent tan squared theta in a different form for us to arrive at our answer. So this is not all yet. So we say here, sin squared theta times sin squared theta all over cos squared theta, because all this is tan squared theta. The whole of this is another way of rewriting tan squared theta is actually sin squared theta over cos squared theta. And that then means I'll be having sin raised to power 4 theta over cos squared theta over cos squared theta. But we say cos, we have that we say but sec squared theta is 1 over cos squared theta. It's 1 over cos squared theta. Therefore, this, the whole of this, yeah, sorry, this side, the whole of this will now bring in the aspect of sec squared theta, so that it is sin raised to power 4 theta sec squared theta. And that is this. Now that's the answer. So up to there, I urge you to follow me to my next video, because I'll be considering more I'll be considering application of more trigonometric identities.